Much better. Welcome to Case of the Unexplained. My name is Mark Russinovich, and I flip to the right machine, which is E. So first let me ask, how many people have been to Case of the Unexplained talk before? How many people have never been to one? So lots of people, lots of newcomers, which is great to see. But even those people that have come before, this is all new material, so you'll be taking away hopefully some new insights, or at least some new jokes. This is the outline for today's presentation. I'm going to start just by setting a context for what I hope that you're going to get out of it, what I hope to convey to you. I'll talk then about real-world troubleshooting cases that will highlight both the tools and the techniques that I'm going to present to you, and divide those into different categories of symptoms, and then go through the cases that represent those symptoms. Some of these were actually sent to me, some of them are my own, and they all illustrate some of the key techniques that I think are very powerful troubleshooting techniques. So I'll start with sluggish performance, application hangs, error messages, got a nice, interesting malware case, and then to cover blue screens. This is, like I said, a brand new talk. This is the 2011 version of a Case of the Unexplained series that I started about 3 or 4 years ago, delivering at TechEds. And the last 3 years are actually available for on-demand viewing. You can go to Mark's webcasts off the sysinternal site and find the links to them. And I recommend if you found something useful in this that you go back and look at those as well, because those are all different cases. In some cases, they're different tools highlighting different techniques that I'm going to be presenting this afternoon. And like I said, these are all real world. They're none that are made up or canned. And I've written up a bunch of these too in my blog. So that's another place to go check for these kinds of cases. Now, the reason that we even have a session like this is that lots of applications do a really bad job of telling you when something's gone wrong. The problem is that developers write their programs assuming that they're going to work in the same kinds of environments that they're testing in. And in those environments, the DLLs are always in the right place. The registry keys always have the right values. But out in the real world, things get screwed up. They get screwed up just through this weird Windows entropy we experience, and they get screwed up because you've got sysadmins that like to do their jobs, and doing their jobs means changing registry settings, changing ACLs on files and directories, because that's going to make the system more secure. And when there's problems that show up, then they've got job security, because they're the ones that have to fix it. There's different types of problems that you can run into. Locked, missing files, registry data that's corrupt, permissions problem's a big one, and I've got an example of that. And the thing is, the errors can show up in all sorts of different ways. From the error dialog box that says hex, gives you a hex code, to the one that says this file's missing when it's really there, completely misleading, to crashes, hangs, or just the system behaving sluggishly. And the purpose of this talk isn't to give you some kind of troubleshooting recipe. That's what a lot of people have come and said, hey, why don't you just make a tool that does the right things? Just you can either enter the symptoms and the tool will take you down and find the right problems. The reality of it is that our systems are so complex, that the interactions are so deep, that they're so specific to an application that there's no general troubleshooting recipe that I can give you. Instead, what I'm going to give you is a way to understand what's going on in the system, so when something goes wrong, you can look at it and apply your brain to figure out what's going on. And some of that means understanding and getting familiar with the patterns of file system registry access, how call stacks work, which is one of the key troubleshooting tools, is call stacks. And with this, with a little bit of effort and some practice, you'll be able to solve cases that seem completely unsolvable from the outside. If you just looked at it from the outside, you'd say, wow, there's no way I could ever solve that. And it turns out that you can. And the tools that we're going to use, of course, are sysinternals. I still continue to work on the sysinternals tools. I started back in 1996. It was NT Internals and then acquired by Microsoft. And it's still me. Originally, it was founded with Bryce Cogswell, and we worked on tools together. Bryce joined Microsoft at the same time. Bryce decided last October that he wanted to just hang out, so he's retired now. He's actually traveling around the world, and I never hear from him anymore, so if you see him out and about, tell him that I'm looking for him. There's some bugs I'd like him to fix. So these tools are all free from sysinternals. Actually, that's an internal Microsoft share. Anybody from Microsoft in here? No? Nobody wants to admit it? It's a hostile crowd. There's another set of tools called the debugging tools for Windows that I'm going to also use a tool from. It's called the Windows Debugger, and that's also a free tool you can download from that URL right there. So let's get started on sluggish performance. And the tool that I'm going to use in this, starting out with this first case, is Process Explorer. How many people have not used Process Explorer before? Anybody? Any? Bueller? Wow. Oh, there's one over here. Okay, you can leave. So, Process Explorer is a tool that I wrote as a Task Manager replacement. You can actually literally replace Task Manager with it. I've got it running right here, and even if I close it, and I can do Control-Shift-Escape or whatever your favorite technique is for launching Process Explorer, and there we go. How many people replaced Task Manager with Process Explorer the way I just did? So quite a few of you. And I'll actually show you later a tool that you can use to figure out exactly how it figures out how to replace Task Manager. So let's take a quick tour over what we're seeing here, just cover some of the basics of what Process Explorer is all about. First of all, the key difference, obviously, is that it's much prettier than Task Manager. There's a lot more color, and that's valuable in and of itself. Task Manager is kind of bland, although I hear that there's a cooler Task Manager in Windows vNext, whatever they're going to call it. This one also has this tree view, this nesting of processes, and that nesting of processes gives you an idea of parent-child relationships, which can be useful for helping identify what is a process, where does it come from, what's it doing. A great example of that is zooming in right here on this part of the process tree. This is the Service Control Manager, services.exe. It's responsible for launching any Windows service hosting process. Windows services being those background daemon-type tasks on Windows that run regardless of whether somebody's logged on. And that means right there that every process that's a child of services.exe is hosting Windows services. And not coincidentally, they're all pink. And the pink is what Process Explorer color it uses to show you that the process is hosting a Windows service. You can see down here these blue processes. Blue means that it's running in the same security context as Process Explorer, which I launched as me. So all those blue processes are running as me, whether I started them directly or not. There's a number of other color filters, and if you want to change the colors of the filters, you can come into here and configure highlighting. So there's difference highlighting, which I'll show you in a second. Packed images for malware, which I'm not going to talk about. Job objects, if you're interested in that. .NET processes are ones that are managed with the CLR loaded into them, are highlighted in yellow. And then if you're interested in DLL performance, Ray-located DLLs can also be highlighted as well. There's tons of columns that you can add, and by default, I pick the ones that are typically the most useful for troubleshooting. That, of course, CPU, showing you, obviously, if your system's running sluggishly, which mine is a little bit right now, what's causing the CPU usage. The private bytes column and the working set column. And those of you that went to the Memory Manager talk know why I added those two columns, to give you an idea of who's causing the biggest impact on system commit, who's causing the biggest impact on RAM usage. For each process, you get a tooltip, gives you a command line and the path to the image. And those can also be added as columns. If you're interested in adding more columns, go to the column picker and you can see that there's all sorts of things you can add, from things like the window title to the status of the window, which is the same status Task Manager uses to say something's not responding. The session ID, here's the command line. You can add a comment that gets associated with the process. Just a lot of different insight into a process. And some of that insight you can get by actually looking at the process properties. So I'll open up the process properties here and just take a really quick look at what you see here on these different tabs. Starting with the Image tab, you see Windows Explorer. The not verified is Process Explorer showing you that it knows how to verify the digital signature on a file, but we haven't asked it to do so yet. If I press verify, it's just checked and said yes, that it really is from Microsoft. There's a certificate there that says it is. The version, the times that it actually was created, so this is the image create time. The path to the image, command line, current directory, which can be useful for troubleshooting because a lot of process DLL loads start with the current directory as their starting point for searching for DLLs. The user and the start time. Start time is, of course, potentially useful for cases where you know something went wrong with the system at a particular time of day, and you can go see what processes maybe started around that time. DEP status, ASLR status, things related to security and defense mechanisms. If you go to the Performance tab, we've got CPU, I/O, virtual memory, physical memory, the handle count. All of these are available as perf counters as well. This is updating in real time, as you can see. performance graphs. This is like mini graphs of what you see in Task Manager, CPU history, private bytes history on a per process basis, and then the I/O activity. And the tooltip here, if you hover, will show you the reads and writes and what time that was. And if you press the mouse button down, then it freezes the tooltip so that you don't have to try to move with the graph. So if I press the button down right now, then I've just frozen it with the tooltip so I can see that that was 3.2K at that point in time. It's really memory and I/O intensive, you can see. We'll get back to the Threads tab in a second. TCP/IP tab, I don't have any endpoints here, but that's what show up here. The Security tab, what groups that I belong to, because I'm looking at one of my processes, and what privileges I've got. Since this is a standard user process, you can see it only has standard user privileges. If I looked in an elevated process, I'd see a lot more. Environment variables, and then the Strings tab is useful for tracking down malware or trying to figure out what some image is that's not identified well. You can look at the strings in the image, find clues there, like you might find registry paths or other identifying characteristics that might give you a hint. Thought I saw something down here. There's the actual manifest for the file. So those are a quick look at the tabs. One of the other things you can do is look at the system information, and that's divided into 4 tabs, a summary, and these are like Task Manager Performance tab, CPU usage, commit usage, physical memory usage, and I/O as a whole. CPU usage, just a single graph, and this allows you to split it into different cores as well. You can see I've got something that's just going crazy on one of the cores. Memory, and then finally I/O. And I/O here showing you the I/O count for the process. Now, actually, I started that as standard user. Let me elevate it so that we can see some of the cool stuff that's in this latest version of Process Explorer, because there was a lot of changes that went into Process Explorer 12 and 14. 14 was released a few months ago. And the big thing in version 14 is that if you run it with elevated writes, you should get, for some reason ETW is not working. You should get oh, there we go. There you get a network and disk activity call here. So it also breaks down I/O by actual what's hitting the disk and actually what's hitting the network. And those are also available on a per process basis as well. So if you go to disk and network, you can see disk and network activity. You can also add those as columns. One of the big changes, though, that is very visible in this is that Process Explorer now uses much more precise time accounting than it used to. The previous way that it used time accounting was the same way that all of the CPU tools in Windows and third parties use, which is based on the time accounting done by the kernel, which is there's a clock tick that goes off every roughly 15 milliseconds. When that clock tick happens, the scheduler looks and sees which thread is running and on a particular CPU, and if it's running in user mode, adds 15 milliseconds to the user mode CPU usage of the process. If it's running in kernel mode, adds 15 milliseconds to the kernel mode score of the process. And the reason that that is really inaccurate is in 15 milliseconds, lots and lots of threads, thousands of threads could actually have run in between, context switching before this thread got a chance to run. But the time accounting just basically says, I'm just going to assume this guy ran for the whole 15 milliseconds. So very inaccurate, rough approximation. But in Windows 7, a new API was added that was missing, that prevented me from doing this earlier, that lets me actually look at the cycles used by each process. And by looking at the total cycles consumed for a 10 millisecond period or 1 second period that Process Explorer updates at, and then looking at the relative usage of a particular process by cycle, I get the most accurate CPU usage that's possible. And so that's what you're seeing here. And with that, I can see sub-second resolution very easily. And I also highlight that with this less than 1.01. What that tells you is that this guy actually is doing something. It's just not enough to be above 0.1% of CPU usage. But it is active, and it's kind of scary just how many things are sitting there doing stuff in the background, when if you use a tool like Task Manager, the system would look completely silent. It's actually not silent. All these guys busy consuming CPU. On Vista, it uses cycle counts to show you that it's time is being consumed in less than a time slice, and in XP it uses context switches. So you can get that kind of approximate behavior on previous versions, but Win 7 and higher is the most reliable. Okay, let's get back to a case, or actually starting on a case. This is the case of the slow website. So a bunch of users call into the admin and they complain that websites are starting to act sluggishly. So the admin's first step is where are these websites hosted? Well, it turns out that they're all hosted on one particular machine. So they go to the machine, run Process Explorer, and see that the system process is spiking to 25%. One of the things that I do when I configure Process Explorer is have it run in the tray, and then I can see spikes in CPU usage like you see here. And if I hover the mouse over, it tells me who's spiking the CPU. You can see that I've got a service host spiking the CPU at 50% here. One of the problems with this system process is that it's a hosting process. And there's other hosting processes in Windows. Just because that process is consuming CPU doesn't tell us about what actually in it's consuming CPU. Service host is another hosting process. It can host multiple Windows services. So the question we've got is, which service is consuming CPU? On my system, and here it's, what in the system process? The system process is the process that hosts kernel threads for device drivers in the operating system kernel. So something in that is consuming CPU. So we need to look deeper into the process. We need to actually take a look at the threads running inside the process. And that's where the Threads tab comes in. Let's go take a look at the service host that I've got consuming CPU. You can see it here. And if I hover the tooltip over it, you can see that there's a bunch of services. Let me get the hover tip there configured. You can see there's a bunch of services loaded in it. And one of those is busy consuming CPU. We can't really tell which one it is right now because there's just not enough evidence here. But if we take a look inside, we can maybe see what's going on. And actually, some of you might have already figured it out. I think I made the name a little too obvious. But what we can do is go take a look at the threads running inside that. So I'm going to double-click and go to the Threads tab. One of the other relatively new features of Process Explorer is that on Vista and higher, it will actually take advantage of a feature called service thread tagging. What Vista does and Windows 7 does is for threads running in service host processes, it will tag them with an ID that can be mapped to the service that they belong to. And Process Explorer shows you for each thread, if it's got a tag, which thread it's associated with. So this case, troubleshooting this used to be a little more difficult than it is now because what we'd have to do is look and see that this service hog thread is consuming CPU, and we'd have to figure out which servicehog.dll was in. Same thing for this. In the past, we'd just look at this start address, which I'll talk more about in a second, and that doesn't tell us anything about what service is causing the CPU usage, so we'd have to dig even deeper to figure that out. But now with the service tagging, you can see very clearly that it's the service hog process. And what I'm going to do now that we've already figured that out is suspend them, because then we can come back and look at them later. Actually, I'll suspend them in a second. Well, this guy wanted to actually figure out what inside of this system process was consuming CPU. So the system process, he opened up the Threads tab for it, and he saw this thread right here. The thread has a start address called ipmi-drv.sys. You can see that there's nice names for the other threads, and that's because they configured Process Explorer to point at the Microsoft Public Symbol Server, which is described on the previous slide how to configure that. And that lets Process Explorer pull down the symbols for various Microsoft Windows and other Microsoft applications and then show you nice names for the functions within them. This is clearly a third-party driver or one that Microsoft hasn't published symbols for because we don't see that nice name, IPMI-DRV. So the question is, IPMI-DRV is pegging one of the CPUs. This is a 4-core system, so this is what it would look like if a thread was going crazy, consuming as much CPU as it wanted. That's going to be 1/4 of the system. So he did some research and figured out that IPMI-drive.sys is actually the Intelligent Platform Management Interface driver, which is a Windows driver. And doing some more research, he found out that that driver is supposed to monitor the system and send information to another component called the Baseboard Management Controller. that's on the blade. He checked to see if there was any updates to the IPME driver. No updates. And then he discovered, again, doing some more research with this BMC thing, that the IPME data goes through the DRAC, which is Dell's BMC, to the chassis management controller, the CMC. So let's just get this straight. The IPME driver sends data to the BIMIC, which in Dell's case is the DRAC, which sends data to the CIMIC. At least that's the way I would say it. And that'd sound really technical if I said it that way, because nobody knows what I'm talking about. So now that he had this clue, the DRAC, what is the DRAC? Well, it's sitting there connected to the blades. And so what he did was just reseat the blade because he figured there was a loose connection between the DRAC and the CMC. And sure enough, that caused the CPU usage to go away. Problem solved. In my case, well, actually, let's take a second look at here. In my case, back at my service host here, I've got 2 threads. We saw that one of them has its nice name inside of Service Hog right there. So I'm going to suspend that one. Now the other one, if we didn't see the fact that it was in this service, we'd have to look at the thread stack, which is this. And then we would see, again, here, that it's the Service Hog DLL. So what we're looking at is the stack of the thread right now when I double-clicked, and this records the function invocations within that thread. So the thread started out in RTL user thread start, which caused TPP worker thread, which called TPP work p execute callback, which called into this DLL. And this DLL is calling get tick count right when I caught it, but it's clearly on the stack, near the top of the stack, which is at the bottom of the screen. Third party, likely the cause of the problem. And so then I can map that back to which service that belongs to. And here are the list of services, including which DLLs they're hosted in. And there you can see Service Hog. And the developer conveniently told us that it was going to do exactly what it's doing. So this next case is also going to take advantage of stacks. Now, this one's an interesting case. It came into Microsoft support to the Exchange team. In this case, the users started to submit help desk tickets because they would see 10 to 30-second pauses in Outlook. And I don't know what's so interesting about that. I see that all the time. But it was a whole bunch of users. Actually, maybe the volume was more than normal. And it was multiple users at different hours. So Microsoft Support's got this pack of perf counters that they can give you and say, configure perfmon to log these counters every 5 seconds. Do it for 24 hours and then send us the log file. So the customer sends the log file. Oops, I didn't mean to do that. It's when you press the end button a little too fast. So the customer sends the log file. And I actually have a copy of it right here. And so here's what they saw. And the problem's pretty obvious at this point, I think. This is a drawing glitch, actually, so that's not really the problem. I don't know what that is. See if that goes away. Nope, that's interesting. A bug in perfmon, I guess. Well, so there's lots of counters here. Tons, you can see. But what I'm going to do is get rid of all of them, and this is what the Exchange engineer did. They just wanted to filter all this stuff out. This is like queue depth, message queue lengths, and RPC times, and all sorts of Exchange stuff. Let me just get rid of everything except for processor time for store.exe, which is the Exchange process, the core engine. And I focused in on a time right here, 8:20:32 to 8:43. Let me change this to be a little more visible. Actually, go to boldest there. And what we can see is that there was a couple of CPU spikes. Now, this graph is scaled to a maximum of 800. This is an 8-core system. So if you had CPU usage on every core, you would have 800%. You'd have 800 as the value here. What we're seeing is CPU usage that's above 100. So that means that things were busy on 2 cores. Probably one core spiked, and the other core was just doing normal activity. But we had 2 of these. And what they noticed, the Exchange engineer, looking at this, that there was a baseline load of about 75%, that these spikes lasted less than a little bit, well, they lasted greater than 10 seconds. They were about 30 seconds, which corresponded to exactly what the users were experiencing. And so what they did was said, I would really love to be able to see what Exchange is doing when those spikes occur. So there's a few ways you can do that. One is you could have the admin sit at the console or sit monitoring this Exchange server with perfmon, and when they see that spike, to go attach a debugger to the process and dump the process. No, that's a very painful manual process. And in fact, what if the spikes were shorter than the reaction time of the admin? Then you wouldn't be able to catch the spikes reliably. So I wrote a tool, and it was actually at the request of the Exchange guys, for just such a scenario called ProcDump. Has anybody used ProcDump? ProcDump's one of my favorite tools because it's got an interesting name, I think. Proc and dump together in one name. And I didn't do that intentionally. It's just the name that most clearly describes what it does, which is take a dump of a process. Now this process, the ProcDump can have multiple triggers to generate dumps from. First, you can just point at a process and generate a dump of that process. And then you can look at it. So it's more convenient than attaching a debugger and doing the dump from there. But the triggers you can set include CPU usage, private memory usage, so private bytes, if they exceed a certain threshold, create a dump of the process. If the process has a first chance exception, generate a process or a second chance exception. If its window becomes hung, oh, and by the way, guess what product team asked for that feature? I'm not going to say it out loud. Somebody else said it. Certain Microsoft Office product asked for that I might have already talked about. Then there's performance. You can actually have it take a dump based on any performance counter you want to. So you can say, generate a dump if this perf counter exceeds this value. And for all of these, you can say durations. You say CPU usage has to exceed this value for this number of seconds. And then generate 5 dumps of that. So what this engineer did was configure this command line, put it in a batch file, and sent it to them. And just reading through this, procdump -n20-s10-c75. N is the number of dumps. S is the length of the CPU spike, which is specified in the C. And you notice it says CPU 75, which is what we saw in the perfmon graph. And then but they said U for relative to a single core. If the CPU usage goes above 75% for a single core versus 75% for all 8 cores, then generate a dump. Actually, let's just quickly demonstrate some of the capabilities of ProcDump. And I'm going to run a tool called CPU Stress, which you can use to create threads that just needlessly consume CPU. And I'm going to type ProcDump, and let's say that we want to generate a dump if the CPU usage exceeds a CPU usage of 25% system-wide for more than 5 seconds. And we want to generate 2 of them. And it's as easy to configure as that. Now it's monitoring. And let's get some load here. If I move that to busy, then we're seeing CPU usage. It's right at the threshold, though. So let's force it above the threshold by creating a second thread. And then we got one of the dumps. Now it's going to continue monitoring. And if we continue with CPU usage for another 10 seconds, boom, or 5 seconds, we get another dump. And so that's what that command did. The admin ran it, generated a bunch of dumps, and let's go take a look at the dump files. Now let's go, what is causing all this CPU? The service host I didn't stop. Let's go stop the service host from consuming CPU. And I'll do that by suspending these threads, which I can do right here to get them out of the way. So the dump that they sent in, actually, they sent a bunch of dumps in. And so the Exchange admin opened all the dumps, and ProcDump shows you in the header of the dump why it generated the dump. So it'll say process exceeded 75% for 10 seconds. It'll give you the thread ID of the thread consuming the CPU. And then it sets the thread context to the thread responsible. So all you have to do is look at the stack, and you're looking at the stack of the thread that was busy consuming CPU. So this is what they saw. And all of the stacks, most of the stacks, looked like this. This guy, being an Exchange engineer, though, had some experience with what Exchange stacks look like, or the functions within them, or what Exchange does. This was the one that was the most interesting to him, this EC find row. Exchange is a database engine. Find row is looking at entries in the database, trying to find one. So he knew that a common problem was with this version of Exchange, which is 2003, that large mailboxes could have been a problem. Users doing searches on their mailboxes and having really big mailboxes that cause these CPU spikes whenever somebody would do a search. So what they did was have the customer follow this Exchange blog post, which is right here, finding high item count folders, to go in, look at the Exchange server, find the folders that have high item counts, and then email the users and say, please clean up your junk. And so the users, well, actually, there's two things that the user could do to either clean out their old stuff or reorganize their messages into fewer folders. And actually, this was a great opportunity to clean up all the spam that had accumulated in the people's folders. So they identified like 10 people that had these giant folders. They went and reorganized them, and over the course of the next several days, these spikes completely disappeared. Problem solved. Let's take a look at application hangs now. And for this one, I'm going to use another tool called Process Monitor. How many people have used Process Monitor before? How many people have not used Process Monitor before? You're still here. Oh. So Process Monitor is a tool that's a real-time file system, registry, thread, DLL monitoring tool. Let's go ahead and run it and see just the basics of Process Monitor. So when you start up, I've got some filters configured. It just starts logging everything that it sees. You can see that it's already 40,000 events configured, so this system is definitely not quiet, and this is pretty standard for Windows 7. It's amazing the performance that Windows 7 gets when it's doing all this stuff in the background. And for each one of these, you get a sequence number, which is the count in the display of the particular line. You see time of day to a very high resolution, the name of the process with a tooltip, the operation, in this case a create file, the path, error code, and then this other column shows you additional detail, which in this case is just about everything related to that open file. What access type was being requested? In this case, it wanted to read the attributes of the file. What was the result? What did it want to do? Did it want to create the file or delete the file, overwrite the file? It wanted to just open it. And the options on the open. What share mode it specified, which can be useful for finding sharing violations. An incredible amount of detail, and that's not all the detail that you can get. If you double-click, this event tab shows you everything that was collected for that particular event. Which thread did it, the duration of the event. This is what's in the Details tab. And if you click on the Process tab, this gives you a lot of detailed information about the process that looks a lot like what you see in Process Explorer. The PID, the parent process ID, which terminal server session it's in, what user account, when it started, if it's still running at the end of the trace or not, what UAC integrity level and virtualization it's got, whether it's 64-bit or 32-bit. And down here, you see the list of DLLs that were loaded in the process at the point in time you double-clicked on that, or at the point in time for that trace entry. So if this process loaded a DLL after this point, you wouldn't see it in this list. You just see the DLLs that were loaded at this point in time. Then finally, we have the Stack tab, which I'll show you in a minute. There's a tremendous number of data mining options, too, and there's a lot of different ways to filter. One of the ways that I filter most commonly is I say, OK, I'm just interested in this particular path, this link file. So you can use these quick filters right here, where you just right-click on the entry you want to filter on whatever field you want to filter on, and then you can include it, exclude it, highlight it, or just copy it to the clipboard, whatever that field is. Exclude events before, so if I'm not interested in anything before this point in time, I can exclude those entries, or afterward. So let's just say include that, and now we've got a filter just for this, and that was the only access of this particular path in that entire trace. Control-R brings back all the data, so the filters are non-destructive. You can apply filters and remove them at will, and if you want more complex filters, you go to the filter dialog. The filter dialog has these complex expressions, like you can say, well, I want the description has to match, and it pre-populates it with descriptions of the different processes, or whatever process name. This is the most common one, which is process name is, and here's the list of processes in the trace. So I just want to see what perfmon did, and then I can say add an include filter or exclude filter. So lots of power here, and this feature is actually particularly useful as well when you configure a bunch of filters, but you want to temporarily remove them without having to delete them and then recreate them. You just disable them. And then when you disable them, those filters are not applied. You can come back into the filter dialog and re-enable them. So that's a quick whirlwind tour. Let's get to our case here, which happened in my own house. So I was downstairs watching a movie with some friends. My wife's up with her friends, and she wants to show them some videos of a recent trip we took. So she runs Windows Live Photo Gallery to try to show her friends the movies. She shows one movie, and then Photo Gallery goes to this, just it frosts over. So she exits Photo Gallery, tries it again, one movie, then bam. So her friends are really annoyed, and one of her friends makes the snide comment, well, I've got a Mac, and this stuff never happens on my Mac. Apple's so much better. So my wife calls me up. My friends are like, what's going on? Well, I got to go fix the computer. So I put the movie on pause. So now I've got my friends waiting to watch the movie, my wife's friends watching to see what I'm going to do, my wife hoping that I make her proud. I'm under a lot of pressure. If I don't solve this, I mean, she's like, oh, my husband's like a really great computer guru. And like, nope, couldn't figure this one out, sorry. A little embarrassing. So I'm like sweating. I hope I can really figure this out. So I run Process Explorer. I go look at Photo Gallery's threads, don't see any clues. And then I run Process Monitor. We've got a saying Dave Solomon and I came up with. Anybody know the saying? How did you know that? No, it's right there on the slide. When in doubt, run Process Monitor. And when my daughter comes home with homework from school, I have her run Process Monitor first. In fact, here, she heard the commotion from the kitchen. She comes running in. Let me solve it, Daddy. And I'm like, no. She's 11 years old, and she's really a sysinternals guru already. So what I did was I started Photo Gallery and captured a Process Monitor trace of the first movie playback. Then I set a filter. Let's go do this, load this file. So Photo Gallery. And then I set a filter for, you can see there's a whole bunch of stuff going on. So I just said, let's just see what Photo Gallery is doing. Let's go to the end of the trace, because that's when the hang happened. And then I scrolled up, and I just was like, okay, so where's something interesting? Just lots of reading of different files. And I came across, eventually, it's going to happen real soon now, references to a COM object. So where's that COM object? There. Here it is. So I see these references to a COM object. And so I say, oh, okay, I see what's going on. There's a clue right here. See, if you read that, it says BAD. So this is a bad key. So they're like, oh, wow, that's really impressive. So then I go to look at the values that are over here being read, and I see this. And I go, aha. Well. So I do a jump to the registry key. I do a jump to, which it won't work here because I'm elevating, and so it's not going to be able to remote control regedit. So you got to do that from elevated process monitor. But what it will do is jump into the registry at that particular path. Let's go back and see what was there. And this was what's there. Program files WL QuickTime Control Host.exe. So I look at Process Explorer, and I see there's a process there called WL QuickTime Control Host running. I terminate that process, and then Photo Gallery unfroze instantly. And we were able to play another movie, but then it froze again. And again, after terminating it, unfroze. So something's screwed up with this WLX QuickTime Control Host. I look at what DLLs are loaded into it, and sure enough, it's that company that doesn't know how to write Windows software. And so I just reinstalled QuickTime, and the problem went away. But went from hang in Photo Gallery following these different steps. I mean, once you get to it, it's like, okay, all I had to do was reinstall it, and the problem went away. But getting to that point was only possible because of Process Monitor and Process Explorer combined. And so I did this in about 5 minutes or less. My wife's friends are like, wow, your husband's really something. My wife, she's like proud of me. I can't like make the doghouse or anything like that, but I can do stuff like this. So anytime I get a chance to show this off is a good thing. And I got back to watching the movie. My friends, I told them the story, and they were all impressed too. And so, so this next one actually came into a sysadmin, or a sysadmin experienced it. He was trying to start ASP.NET website and kept getting this error. ASP.NET State Service failed to start, which is the session state provider service for for IIS. And he looks at the log file and he says this. He sees this: the specified user account is expired. So like, what the heck is that? So he checks the Kerberos settings, checks the account that it's running in. No problems. I mean, no clue, no connection to that event log entry. So he captured a procmon trace of the process startup. And let's go take a look at that one. Now, this case, I'm going to highlight some of the other filtering capabilities of Process Monitor. You could do for a case like this, that you're getting some bizarre error that has nothing to do with the original case. So it's obviously an error condition. You could do one of two things that I follow, which is, one is just to start eliminating error results, result codes that you know can't be responsible for, like, okay, whoops, I didn't mean to do that, I meant to exclude it. You want to exclude success, exclude buffer overflow. By the way, buffer overflow sounds like a really scary thing. Buffer overflows in this case is just a standard part of the way that Windows operates. Not that it has lots of buffer overflows, but the fact that when a process queries a registry key, it specifies how big a buffer it's passing in. And if the data fits, then the result will succeed. But if the data is bigger than the buffer, then you get back this error message. The program knows to allocate a bigger buffer and go try again. So you'll always see buffer overflows followed by a success. Well, almost always. So you could go one by one like that. But one of the things that I'll do as an alternative to highlight another one of these data mining tools is to look at the count occurrences here. This lets you see all the values of a particular attribute in the trace. And what we want to see is all the result types. And so it will show us all the results that occurred in this trace, including their count. And so you see buffer overflows, end of files, no more entries, path not found, reparse. Well, access denieds in cases like this are always something that should be investigated. So where are these access denieds? You can set a filter actually just by double clicking. And now we see our 2 access denieds. And the admin in this case went through the log looking and found the access denieds. You can see there's an access denied here on the ASP.NET state.exe executable. So at this point, he had a strong clue. So he goes and looks at the permissions on that ASP.NET exe file, and the permissions are on this left side. You can see that there's TS user, system, and administrators. Then he goes and looks at, on another web server, the settings on it, and he sees this. So the difference is that this user's account is here, whereas this is TS user for some reason. Something got screwed up. So he changes the permissions to match the right side on the right, and the problem solved. This is one of those cases of like, how did the permissions get screwed up on this? And a lot of cases it's just weird drift of things or somebody else coming in and messing with things up. Actually, I figured out after the fact, this was in the time period when I was offering to give out a free copy of Windows Internals to anybody that sent me a case. So I think he intentionally messed it up, did the case, and then said, like, oh, I figured this out. Give me a book. No, actually, I don't think he did that. But I'm sure that you've all run into cases where you're like, how the hell did that ever get changed? And you blame it on the admin next door. This case came from a user that was trying to open files or folders on their desktop, and they would get this error every time they tried to open any folder in Explorer, which is, this file does not have a program associated with it for performing the action. Please install a program. No matter what they opened, they would get this error. So they decided to capture a process monitor trace. They've got another system that's obviously working pretty well, able to open folders. And so they applied one of the key troubleshooting techniques with Process Monitor, which is take a trace from the system where it works, take a trace for the system where it's not working, and then compare them and find out where there's differences. And wherever there's a difference, try to understand why there might be a difference. One of the things, actually, that people have asked me for is something that would automatically generate the diff, basically, of two files. And I haven't done that, but at Microsoft there's scripts that people have written that do this kind of thing, so I might do it eventually. But let's go take a look at those two files side by side. So I've got badfolder.pml, and I've got goodfolder.pml. I never get a chance to use AeroSnap. How many people use AeroSnap? So some of you use AeroSnap. I never use AeroSnap except for cases like this where I want to do side-by-side comparison. So it's actually a lot of fun for me to be able to do this. And while I'm here, let me do AeroShake. Come back. Hello. There. Maybe I shook it too hard. I can know to do that. Okay, so I've got my two traces side by side. And what he did was go and find some commonality between the two. And I'm going to take us down to the place where things started to diverge. Whoops. Wait, I mistyped. Oh, I am looking at the wrong one. Sorry. No wonder. So where's here? There we go. Okay, so let's take a look. I'm going to move these results over a little bit so we can see a little bit better what's going on with the results. And let's take a look at how similar or different these two sides are. Oops. Okay, so let's line them up. And actually, that doesn't look too lined up. Shell folder open. Let me make sure I'm on the right one. Yeah, shell open command. All right. Shell open command. And now we should be lined up. And actually, we are. You can already see that we're lined up where the shape of things on the left is same as the shape of things on the right. And actually, that's the easiest way to get a quick look at whether things are lining up or not, is just are the shapes of the paths lining up together. And if you scroll down a little bit more, the shapes are going to start to diverge. And they start to diverge. All right. Mouse is going crazy on me. Open. Right here is where they diverge. And why is this jumping around? There we go. Shell open command. And this side, we see a query to hkeyCurrentUser software classes folder shell open command supported protocols that's not found. Here we see the same thing, which I'm not lined up. There it is. Shell open command. You know what? Why am I not lined up here? This is the bad one. All right. One more time. Got it this time. Okay, reg open key of this shell hkeyCurrentUser shell open command. The result is success. On this side, the result is name not found. And if we scroll down a little bit further, this is where the shape of things just starts to diverge. You see this thing opening some delegate execute thing, shell explorer. This thing is going after some supported protocol keys. And so the paths are completely diverged, and it all started with this not found on one side, on the bad side on the left, where there was a success on the good side. So what he did was do a regedit jump into the registry, exported that branch of the registry, and imported it into the other system, and the problem was solved. So something was wrong with the shell open command handler, which is what happens when you double-click on something on the desktop, and the problem was fixed using this comparison with just a few minutes of comparing side by side. In this next case, an admin was managing a VMware ESX server, not that I approve of that, and they tried to copy some firmware files to the server using this freeware FTP tool, WinSCP. Anybody use WinSCP in here? So I didn't realize how popular this tool was. But they got an error from WinSCP, which is the application was unable to start correctly. Hex U005, click OK to close the application. So completely useless error message. One of the most common types, just some hex number, and press OK when it's not OK, actually. I wish I could say, no, it's not OK. But he'd seen a case of the unexplained talk, so when in doubt, run process monitor. He captures a trace with process monitor, and he goes to the end of the trace. This is the technique you use whenever you see an error dialog box like that, and the process is still running, but it's got some error dialog box. Go to the end of the trace and start working backwards. In this case, what he did, though, was he didn't see anything unusual here at the end of the trace. No clues, no weird error messages, no missing files. Well, external manifest, but that's not a big deal. Everything looks cool. And he searched even further back and didn't see anything unusual. So he relied on process monitor's stack trace to see if there was any third-party components loaded in this process that might have been responsible for the problem. So double-clicked, opened the event properties, and went to the stack button. Now the stack, if you configure process monitor, you can configure it with symbols, and for some reason the NTDLL symbols aren't resolving from the symbol server, so that's why we're seeing this weird thing here. But what you do is look for third-party components, and NTDLL is NTDLL is built into Windows. And so that's probably not the issue. That's not a third-party component. This kernel stuff, well, that's not part of the issue either. But there's two components here that he didn't recognize, sysplant.sys and sysfur.dll. Let's take a look at what those are. Sysplant, anybody recognize these things? Oh, I hear some groaning and some And then this one, same thing. So these guys are related to each other. So here's got some clues. WinSCP is failing to start, and he's got the semantic firewall product. Why did I do that? My hands are clicking a little too fast. He's got the semantic firewall product loaded. So with that in hand, he goes and does a Bing search. He Bings it. And actually, I think it's okay to say that he Googled it with Bing. And he came across this, which is posting in a semantic news group, apparently, and somebody saying, hey, there's this problem, it's describing the exact same thing, and there's a fix down here. One of the semantic guys say, hey, or somebody else did, because I guess semantic guys aren't that helpful, says, hey, here's a fix over here, and so he goes and gets the fix, and there's a KB article and everything, and sees 005, and so. And it's actually not just WinSCP, it's any application can be affected by this. So the stack led him right to the problem, something that would have been impossible to find without that. Now let's take a look at another case that it's interesting. But actually, before I want to move on to that case, let me stop and show you one of the, I think, cool features of Process Monitor. Let me close some of these existing ones and show you one of my filtering tips, which is one that I use a lot. There's actually two filtering tips I'll show you before I move on. One is the filtering tip where you want to highlight a particular process, like Notepad, and that is this window bullseye right here, which you can drag over a process, and that sets a filter just for that process. That's one. The other one is the process tree. So the process tree is obviously very useful in Process Explorer. You get the same thing here. This shows you every process that existed during the trace, whether it was active or not, whether it was just sitting there silently, it's going to show up with timelines, which are relative to the booting of the system, or if you want, just the captured amount. So you can see some DLL hosts exited after I started Process Monitor. Those DLL hosts are actually related to UAC elevation, which is why they were born and then died. You see a whole bunch of information about the processes, and in the process tree now, let's say that I wanted to just see activity from Internet Explorer. So I could say include subtree and close, and now I'm just seeing activity from those Internet Explorer parent and its children processes. So that's another convenient filtering tip that I use a lot. This next case is one that was really kind of blew my mind because it's such a sideways approach to the problem. It starts with a user asking a friend to take a look at their machine. How many people have had a user ask you to look at their machine because it's infected with malware? And how many of you say, no, I'm not going to look at it? Wow, that's not cool. I mean, at least ask them to give you a beer in return or something. So actually, I want to make a shirt that says, yes, I will fix your computer. And then, because I look forward to these things. But in this case, this friend was nice enough, nicer than you guys out there, to look at the machine. And the machine, when they started to use it, boots and logons just took forever. So one of the first things you do, if you've got a malware situation, which he suspected it was a malware situation, is try to just run virus scanners. Just go run the free ones. And actually, it turns out that the best one is a free one, the Microsoft Security Essentials. Little advertisement. This is brought to you by Microsoft, after all. So he ran Microsoft Security Essentials, scan on the system, but it hung part of the way through. It just started processing and then just never came back. Just went out to lunch. He runs Task Manager. That's actually a bad sign right there that he didn't run Process Explorer, but he earned it back, as you'll see. So then he tried running the sysinternals tools. So he goes and downloads them, but every one he tries to launch, it would flash and then disappear. Has anybody seen this before? Yeah. So you know that, I mean, you can come and tell me the tools are awesome all day long and that feels really good, but when the malware authors start to block the tools, I know that I'm having an impact on things. So he can't run any of them. Auto runs, Process Monitor, Process Explorer. He actually got it. So there's lots of different ways malware can block sysinternals tools. One is just by name, by looking at the title bar of the window, by looking for strings in the image. In this case, he tried to test how the malware was identifying the tools. He created a file called Process Explorer, tried to open it in Notepad, and Notepad would poof disappear. So clearly this malware was looking at window titles to try to figure it out. So he's like, all right, so I can't use the tools that I normally use to troubleshoot this thing. What do I do? So this is where it's just really cool. He goes to the sysinternals suite. So there's a link off the sysinternals website, which is the index of all the utilities. And he's starting with A and going to Z. Zoom it for Z. Auto runs for A. And he starts scanning through them. Have I tried that one? Is that one maybe useful for malware? Is that one? Is that one? And he gets about quarter of the way down the list, and he comes across desktops.exe. Has anybody used desktops? So a few of you. So he says, I wonder if desktops will work. What is desktops? It's a tool, I actually have it running here, and it creates 4 virtual desktops using the real desktops object that Windows supports. Windows actually has this object type called a desktop, which creates fully isolated desktops, each with their own set of windows that can't see each other. And let's create a second desktop. I just press on that, and then we have a second desktop, isolated from the first one. If I want to go back to the first one, I just click on that and go back to the first one. I can use hotkeys too, like I can say Alt-1, Alt-2, Alt-1, Alt-3, create a new one, Alt-2, Alt-1, 1, 2, 1. And the hotkeys are really useful if you've got a screen that people can see when they come by your desk. So he launches a second desktop, and sure enough, he's able to run the tools on the second desktop. So he captures a process monitor trace. Let's go see that one. And he captures a trace, and he just sees it's just this barrage of registry access, all coming from the WinLogon process. And look, it's hitting this particular registry value over and over, this WinLogon notify blah, 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 blah. So he jumps into the registry to take a look at what's there, and he sees that there's a DLL registered there. That looks a little suspicious. And so what he did was try to delete that key, but after refresh, it came right back. So he's like, all right, so maybe this malware is smarter than me, but maybe Security Essentials, if I give it a push in the right direction, it'll work. So he With Security Essentials, as with most malware scanners, you can point it at a particular file. So he launches Security Essentials, points it at the file, and Security Essentials says, yeah, I know what that is. It's the swimnag gen.a.dll, which is a severe virus, and we recommend you remove it. And so, so he removes it, and sure enough, he's able to delete the register key after that. System's back to normal, problem solved. So a little hint from desktops of all tools to solve that one. This next section has to do with blue screens. How many people have had a blue screen in the last day? How about nobody? One person? How about the last week? Yes, yesterday's within the last week, yes. How about the last month? Last 2 months? 6 months? Year? Let's get everybody to raise our hands. How many of you experienced a crash on Win 7 or Server 2008 R2? Because it's, all right, never mind. Hope that didn't get caught on camera. Well, so why does Windows crash? Windows crashes when something goes horribly wrong in kernel mode. And something goes horribly wrong in kernel mode when, and it's actually detected as being horribly wrong, some component says, wait a minute, things are screwed up. And we're in kernel mode where there's infinite power on the system. And if things are screwed up and there's infinite power, there can be unmitigated destruction of user data. And so our onus is, number one job of the Windows kernel is to protect your data. And so when it detects this situation, will try to stop everything in its tracks so that there's minimize the chance of corruption of data, which might have already occurred because these device drivers could have access to user buffers, buffers on the way to the disk, whatever, or cause applications to screw up and corrupt their data. Now, the kinds of problems that can be detected and cause this blue screen are invalid access of memory addresses. This is one of the most common. So a driver just has a bad pointer, programmer screwed up on reference count of some things, referencing some deleted block of data, or going past the end of a buffer, or not accessing the memory at the right interrupt request level. There's certain rules about when you can access certain kinds of memory from kernel mode. And that will cause the memory manager to say, okay, there's a problem, let's crash the machine. And the crashing the machine is turning the screen blue and dumping the machine. Now, when you reboot after a crash in Windows, of course, you get offered, hey, would you like to send this to Microsoft? Or it just happens automatically on newer versions of Windows. And sometimes you get taken to the Action Center, or you get told a message, hey, we've got a fix or some resolution. This example right here, this was one of the first times that I ever experienced a blue screen after Windows XP, or this is actually Windows Vista. And the thing told me, hey, this is a bad video driver, and there's a fix. That, by the way, video drivers are one of the most common cases of crashes. Actually, there's two cases, video drivers and security software are the two cases where cause most of the crashes. And so this case, and you can see that I'm blanking the name of this company so you can't see what it is. But a lot of times, these automated crash analysis can't help you, or you just don't want to wait around for it to come back with an answer. This is my favorite one, problem caused by a device driver. It's like, well, okay, thank you. What do I do with that? Uninstall all my device drivers? This is not going to work very well. So this next step is just not to let it go, not to hope it doesn't happen again, but just to spend a few minutes to see if you can figure out what happened. And it's actually incredibly easy to do some basic crash dump analysis. Amazingly easy. First step is to get the crash dump analysis tools. The debugging tools for Windows package, which I've already shown you, WinDebug, configure it to point at the public symbol server. Let's just take a quick look at that, which I've already got configured here. But if you go to Edit Symbol File Path, there's the magical path, and you don't have to memorize that. That's in the help file, and it's on the web. But I configure it with that. Step 2, find the crash dump file. There used to be all these weird rules about client saves dump here, server saves dumps over here, Now, you don't have to really remember any special rules. I've come up with a simple formula for you to find it. Just look in Windows directory. If there's a memory.dump file there, look at that. If there's no memory.dump file there, look for a subdirectory called minidump, and then load the most recent minidump file there. Windows will save multiple minidump files there. I often go back and look through them and relish and kind of feel that air of success of having conquered those blue screens in the past every now and then, going through the minidump files. So you might want to save them too as trophies for the ones you solve. So that's the other place to look. Now we've got our two things. This next step is potentially the hardest of those three, and that is loading it into the debugger. Well, in this case, server experienced 3 crashes in a couple days, and the administrator saw a case of the unexplained, so he opened the dump. Let's go open that dump and see what he saw. This is the hard step. Okay, get ready. Open. What? Oh, sorry. See, I screwed it up. It's that hard. It's Control D. It's open crash dump. I picked the wrong. It's this one. Open crash dump. I did open that. So Control D, and then Hyper-V .dump. And there. I did it right that time. Now what happens is the debugger is actually going to apply its own heuristics to try to figure out and give you a hint about what's gone wrong. You see this analyze-v. Well, first of all, let's see what it says. It says there was a bug check, 101. Who knows what that is? Bunch of parameters with the bug check code. Probably caused by this. Well, this is a case of a false positive or something that's useless information. What I always do, click on this analyze-v, which will at least give you some more information like, oh, that 101, actually that is clock watchdog timeout. And what is that? An expected clock interrupt was not received on a secondary processor in a multiprocessor system within the allocated interval. This indicates the specified processor is hung and not processing interrupts. So we still don't know what caused it, but we have some clue. And this is where a little binging will help. And I just wanted to show you today's picture there. It's nice and pretty. x64 clock watchdog timeout. He did a search, and there it is, hotfix for clock watchdog timeout. And applied the hotfix, no more problems. Instantly solved. I know doesn't seem sexy, but when you've got a server that's blue screening, that is, you'll take whatever you can get. This next case is a Citrix server farm with servers started sporadically crashing. Again, this is another admin that had seen the case of the unexplained and decided to investigate. So he opens the dump file for this one. And this is bug check AB. Anybody know what that is? Anybody? Free book? Session has valid pool and exit. Actually, that doesn't seem like an error to me. That's like, well, it should have valid pool. What if it had invalid pool? Is that okay? So caused by session driver not freeing its pool. So again, no clue. It's pointing at win32k.sys. He's got the latest hotfixes for Windows. So he does he does the same thing. He does a search here with the clues he's got, which is just session has valid pool and exit and Citrix. And there's the hotfix. Presentation server crashes with bug check AB, and this actually lists out exactly what he saw right there. That's the exact same thing that we see in the stack, and there's a hotfix. And so again, just a few seconds, and he was able to solve that crash. How many people have seen a crash in real life, by the way, out in public, in a public place? And how about in the last week? Anybody seen one in Atlanta, someplace? Billboard, you saw LED billboard last few days? Oh, a while ago, okay, in Atlanta. I've got a collection, though, that you might have heard of. I like to share. Actually, and I've got, this collection is ginormous at this point. I'm just showing you sampling. This one happened after I gave a case of the unexplained. Somebody went back to the hotel after the talk and took this picture. This is in the hotel directory. I just had to throw that. That's just crazy. I wonder where I can get that tattoo. Here's a Coke machine. It's the real thing there, I guess. I know there's some people from IKEA here. Yeah. This is in Heathrow. This is one of my trips. It goes well with the Christmas decorations, though. Anybody recognize this scene? Yeah, the Beijing Olympics. There it is on the inside of the dome. There it is up close. Technical information. Oh, they left off the crash code, so I can't see what it is. New York Times subway station. CompUSA's bestseller. This is why they went out of business, obviously. I don't know how they sold that thing. And actually, I've got one more. This is Dave Solomon. He's checking into the airport. His wife sees the crash on the screen. He looks at it, figures out the cause, turns to the people in line, and is explaining it to them. And then this is Dave wearing the Blue Screen to Death shirt. He's so proud of himself that he had that made into a T-shirt, and he walks around and tells everybody the story whenever you see him. So that actually brings us to the end of the talk, and I wanted to just point out I'm going to show you something kind of cool after I wrap up here, but there's a book that Aaron Margosas and I have been working on. It's coming out literally next few weeks, June 15th publication date. This is the Sysinternals Administrator's Reference. Aaron did actually the bulk of the writing. I told him what to write, which is what happens when you get to this stage in your career. You can tell people to do stuff like that, and then I get my name bigger anyway. So thank you. Where are you, Aaron? Aaron's somewhere over here. Where? There. Aaron, stand up and say hi to everybody. So this book is really, it's exceeded my expectations in terms of the quality of the material that we got, largely because of Aaron's dedication to it. And so it's going to be a great book. It's got chapters, full chapters on the individual tools. All 65 tools are covered in the book, and some of them in less detail than others. Some of them merited their own chapters. And there's also a Case and Then Explained section with a bunch of cases like the ones I've been showing you. So that's a great thing that's coming out next month. Now, I'm going to sit in your seats if you want to see something, because I'm going to show you a colorful Blue Screen to Death in a second, if you'd like to see that. But what I hope you got out of this is the fact that there's no recipe. It's a matter of learning about the tools, learning some basic techniques about how to use them. You saw things like going to the end of the log file, looking for error messages, got some feel for filtering, got some feel for looking at stack traces and finding hints in stack traces, using Bing to help you solve problems. See, Bing's useful too. And you get to see pretty pictures on the way. And there's a bunch of resources that you can learn more. Just to repeat what I talked about at the beginning, there's the webcast, there's my blog, then there's the Windows Internals book, which is the best book on Windows Internals, called Windows Internals, that I think there exists. And if you solve a case, please send me log files and screenshots, because then I can incorporate them into the presentation like this. Now, we'll show you one more thing. How many people have heard of Not My Fault? So a few of you have heard of Not My Fault. And around last holiday time, I don't know what, I never know what it's like, yeah, whatever. Yeah, do you want to save some files? Thanks. So around last holidays, I made Not My Fault, a special version of the Not My Fault tool, which is a tool that I wrote for the Windows Internals book and the training, which lets you release where is this? Release x64, release Not My Fault. And what this tool lets you do is crash the machine in various ways. You can actually script it, so you can run it on other people's machines with psexec. No, and seriously, it does support scriptable mode, and Microsoft Support uses this when they get machines that are unresponsive and just able barely enough to run this and generate a crash to look at. But what I did is I added this button right here, where you can pick the colors of the blue screen. So we could pick the colors, but I could put an Easter egg in. If you select foreground and background as black, and then say, OK, now this won't show up on the monitor, so I'm going to disconnect and then have to flip the laptop around so you can see it. And I'm going to press debug. And then this is the Easter egg that you can show your friends.